In this video, we're going to cover Chapter 1, Section 3. We're going to focus on our goals of understanding better statistics, population versus sample, and describing different sampling methods. That's the way we draw our sample from the population. Now, Section 3 talks about populations, samples, and how we actually sample data from a population. So we haven't properly defined population and sample yet. The population is all the things that we're interested in studying. So we could be talking about studying the next election coming up. The population would be all likely voters in that next election. A sample of that is really just a subset. So if we're talking about that voting population, we might choose 1,000 people randomly from the likely voters in the next election. Those 1,000 that we choose randomly are a sample. Now, if we actually have the entire population of interest, we can calculate a number from that. That number would be a parameter. So, population parameter. Notice the alliteration, but it's population parameter. If we only have a sample and we calculate that same kind of summary measure, that same numerical measure, we are calculating a statistic. So if we could actually figure out what every single voter or every single likely voter in the next election thought, we could calculate a parameter. Since we don't, then we calculate a sample, we'll get a statistic. And those two numbers are representing a similar kind of measure, but one includes only a few people and the other includes everybody. So just to give you a picture of population versus sample, the book provides this simple illustration. The left circle, it's actually an oval, I guess. The left oval shows the population of lowercase letters of the alphabet. So you see all of them written in there. The right circle shows a sample of those lowercase letters. You just see a few of them, not all of them. But we could get an idea of what the English alphabet looks like by looking at that sample of letters, even if we didn't know what the entire population of letters look like. So why do we take a sample instead of asking everybody? Taking a sample is much less time-consuming than asking every single person. And some people aren't going to respond no matter what we do. I said in the last video, hey, I could bring a scale to class and try to get the average weight of a college student by taking the weights of all the students in class. Well, some of the students in the class are not going to get on the scale. You know who you are. Also, it's less costly to administer a sample, a survey to a sample of data rather than trying to get everybody. We can actually say a lot with a sample, as long as that sample accurately represents the population. So sampling techniques, or sampling method, really. This is actually how we're going to pick the sample from the population. In other words, who are we going to ask these questions to that we want the answers from? There are two sorts of general categories of techniques. There's statistically based techniques. Those are techniques where individuals or items have a probability of getting selected, and we choose people based on that probability. And then there are non-statistical techniques where we don't really think about the probability of each person getting selected. We use other means. Each of these people are chosen without being concerned about the probability necessarily, but maybe there's another criteria for why we've selected them. We've got two discussions in the book of non-statistical sampling, convenience and judgment. We've got 4 instances of statistical sampling. These are the primary ways that we sample in business. Convenience. Well, this is collecting data in the way that's most convenient for the researcher. So for example, if we want to collect that information about cafeteria food, maybe I want to do this research, that's a possibility. I could just, hey, I've got you in class, you're a captive audience, it's convenient for me. I'll ask you guys about your satisfaction with cafeteria food. That would be a convenience sample. You're in the room and it's convenient. Judgment requires the person who's doing the research to use their best judgment about who would be best to think about asking these questions. Right? Who's most likely to provide me with the needed information? So you could think about this. You get a job and you're responsible for billing people who buy stuff from you. Your boss comes in and says, you need to audit all of the accounts for errors in billing this month because we want to make sure. This is just, an annual audit. We make sure everything matches up. You go, oh my gosh, there's no way in 30 days this month I can audit every single account. There are tens of thousands of accounts maybe. So what you do is go, okay, where are there most likely problems in the accounts? Let's see. Probably the biggest accounts have the most transactions. The accounts that have the most transactions are probably likely to have the most errors. So what I'm going to do is choose the 200 largest accounts. And I'll just go through those 200 largest accounts. I can do about 10 accounts per day. There are 20 working days this month. I'll get through those largest 10 accounts, and hopefully that will tell me about how many errors we're making in general. Okay, so now let's talk about those 4 statistical sampling methods, now that you've got an idea of some non-statistical methods. Simple random sampling. So you see a pair of die down there. You can think about this as truly just random. Often I think about this as drawing names out of a hat. Each item or person has an equal chance of being selected. Often in business or in economics, we use the random number generator from Excel to find out who we should actually pick. So we assign each person a number. We use the random number generator to grab numbers out of that list, and we administer the survey to those people. Another way that we do this is something called stratified random sampling. So we divide the population into subgroups. Strata is actually just a word that means subgroups. And this might be by some kind of characteristic. So I was thinking about voting in the next election again. People age 18 to 39 typically vote Democrat. People 40 to 49 typically vote Republican. People 50 to 65 years old again vote Democratic. And people over 65 often vote Republican. So we could break our population of interest up into those age groups to try to get a better understanding of all of the people in our voting population and how they think, how they feel about this next election. Once we break the population up into those 4 groups, we take a random sample from each of those groups to represent the entire population. Another technique we use is systematic random sampling. So when you think about systematic random sampling, you should think we're going to select every 10th person to talk to. That's the idea you want to be thinking about when you think about systematic random sampling. How do we do this? So we've got our sample size figured out. The little red letter here represents our sample size. Pretend that we want 8 people drawn from a population of 64. So there are 64 little guys standing over here. We want 8 of them drawn from this group. Okay, how are we going to do that? So we take N, the big N, that's our population number. We divide it by little n, that's our sample size, that's how many people we want to get. And that's going to give us this K. So in this case, 64 divided by 8 is 8. The K is actually how many individuals are going to be in the group, okay? And we're going to draw one person from that group randomly. So we use a random number generator or something like that to pick one of those people. So pretend I use the random number generator. I got 3, because I'm looking at 1 through 8 here. I got 3. I need 8 groups. That's N8. I need 8 groups because I'm going to pick one from each group. I get my number 3 guy here, and then I go every kth item. Every kth item. So I'm going to pick the third guy and then the 11th guy and so on. And that's going to allow me to pick randomly, but systematically, 8 people to survey. Cluster sampling is often a geographical kind of sampling. The book uses an example of asking season ticket holders how they feel about something at the stadium, and instead of going to randomly selected season ticket holders, they would go to certain clusters and ask everybody in those clusters. Another example of this is actually companies that have multiple locations. So let's say, for example, that you work in human resources for your company. Your company has 16 geographical locations, so there should be 16 rectangles here. You want to know how people in the company feel about the healthcare plan at work, and you're going to interview those people to find out. Instead of taking a random sampling from all of the possible geographic locations and having to spend lots and lots of nights in hotels, cost the company a lot of money, and be away from your family for a long time, you randomly select several locations of your company. You only have to make a few trips that way. You can go and ask all of the levels of management and the day-to-day workers in those sites without having to be gone so much, and you get a representative sample of how people really feel about the healthcare plan. So that's cluster sampling. You're going to randomly select the clusters and then go and ask people at the chosen cluster how they think.